Okay, this is the Unit 4 review packet, starting with topic 10A. So, first question is sketch a graph for a quadratic with two unique real zeros. So, this means that it is an even function, right? This means x to the fourth is my highest exponent. That is even. So I know it's going to look like a touchdown with both ends pointing in the same direction. And if it has two unique real zeros, then that means it touches the x-axis in two spots. So it could touch here, it could touch here, and then both ends, same direction. B, a quadratic with two complex zeros. So quadratic is x squared. So again, it's an even function. They're either both going to face up or both face down. So two complex zeros means it never touches the x-axis. So it could be like this, underneath, never touches. And it's quadratic, so both ends are facing in the same direction. So this is like a upside down touchdown. C, a quadratic with one real zero with a multiplicity of 2. So again, quadratic is x squared. One real zero means it touches in one spot, and a multiplicity of 2 means it's going to bounce off the x-axis. So that is that one spot where it touches. So let's say it touches here at x equals -2, goes down, touches, and bounces off. And that's one real zero because it touches in one spot. And my last one here, a positive third degree function with one real and two imaginary zeros. So third degree function is odd, x to the third, that's an odd function, so that's disco. One's going to point in one direction, the other end's going to point in the other direction. So if it has one real and two imaginary zeros, that means it touches in one spot, so maybe it touches here, and then it's got two imaginary, so maybe it goes like this. So, and it's got two turns. So this is x to the third. I've got max turns is 2, one turn, 2 turns. So that's an example of something that could be there. All right, topic 10AE, graph each equation. So to find my zeros, it's already nicely factored for me. So all I need to do is set each factor equal to 0 and solve. So for example, I'm going to do some of the work down here. So for zeros, I would do x minus 2 equals 0, x plus 3 equals 0, x minus 1 equals 0. These are all easy one-step equations, right? I get x equals 2, x equals -3, x equals 1. So those are my zeros, and I want to write them as a coordinate pair. So I've got 2, 0, -3, 0, and 1, 0. This one has a multiplicity of 2. See that squared right there? It's a multiplicity of 2. That means it's going to bounce at that spot. So I like to keep note of those for when I'm graphing. So a multiplicity of 2, it's going to bounce. My y-intercept. To do my y-intercept, all my x's are 0. And I'm trying to find what y is. So I've got y equals 0 minus 2, 0 plus 3, 0 minus 1 squared. And when I solve that, I get -2 times +3 is -6, and -1 squared is 1. So -6 times 1 is still just -6. So my y-intercept is 0, -6. On this one, you can do our patterns and say, okay, I know that this is my right end behavior, right, as x approaches infinity. This is my left end behavior. So I can figure out if this is an odd or even function by kind of seeing how many x's I have. X, and this is 2 x's here. So x times x is x squared, and then I've got another x squared. This is x to the fourth. It's going to be an even function with a positive leading coefficient, which means that both of my ends are going to point up, which means that both of these are going to go toward infinity. But you can also just graph this in your calculator. You don't have to memorize those patterns. I can go to y equals and put x minus 2, x plus 3, and x minus 1 squared, hit graph, and see what my end behavior is. So I can see that it's going down, 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 and then up, and back up. So it's going up forever in both directions, which means as I go to the right, this is going to infinity, and as I go to the left, that is also going toward infinity. So those are my end behaviors. And then my maximum and minimums, you do need to have in your calculator for this. So I also like to kind of adjust my screen a little bit. So I'm going to adjust my screen just a tad before I even do max and min. I can see that my x value is only going to 2, my y value is only going a little past 3. So I'm going to reset my window to go to maybe -4 to 3 to kind of widen this out a little bit. And then I'm also going to make sure I see the bottom of this. And right now I can't see it. So I'm going to go to my table and kind of see maybe how far down my y's go. And it looks like I have -36, -24, -6. I'm going to go back to my window and change my y minimum to maybe -40 and see if that lets me see the bottom. Yes. So this is a much better picture of what's happening, and I can see it a lot better. So I do recommend changing your window and kind of zooming in to see what's going on. So my local max and my local min. This right here is a local min because it goes down and it's a turn right here. And then I have actually another one here. It kind of goes, this one's even kind of hard to see here. It goes up and then goes down and then back up. So I have 2 local minimums I need to calculate and 1 local maximum. So my minimum here, second calc number 3, I want to be left of that turning point down there. So I'm going to go somewhere left and push enter. I'm going to go somewhere right and push enter. Enter one more time, and it tells me what it is. So one of my minimums is at -1.9, comma, -36.1. Here's my other one I'm going to calculate. So that again is second calc 3. I'm going to need to move my cursor up. I want to be the left of that little hump, push enter. Go to the right of that hump, push enter one more time, and it tells me that this one is positive 1.7, comma, -0.7. So right from my calculator, I'm rounding. 1.7, -0.7. My maximum, my local maximum is that right there. So second calc 4. You want to be left of that turn, push enter, right of that turn, push enter again. And on this one, when you see things like this on your calculator, check your table. This is basically 1.000003 or 1. We're going to round it anyway. But sometimes the calculator, whatever program it uses, whatever algorithm, does this even when the point is just supposed to be 1 with no decimals. And this right here, when you see these numbers, -2.96 times 10 to the -13, that is a number that is very small. It is close to 0, and a lot of times it means it actually is 0. So the easiest way to check this is to actually go to your calculator and see, is 1 0 a point on this? So go to table. Yeah, 1 0 is a point. So I'm just going to write 1 0. So now when I graph it, I definitely need to put my zeros in, and it helps to kind of look at the graph while you're doing it. And you may want to go back to your normal window because obviously this graph is not zoomed in. So to actually see accurately, maybe you want to go back and hit zoom 6 and see what it looks like in a more smushed up version, since that's what it's going to look like here. So I've got a 0 at 2 0, -3 0, and 1 0. My y-intercept is at 1 2 3 4 5 6. This is going to affect me later, but let's first look at where my maximums are. I have a maximum at 1. So that's here, and that was, remember we said that was where we have a bounce. We have a bounce right here. That's one of my zeros. And then a minimum at -1.9. So here's -1, and -1.9 is close to 2, and it's going way, way down. It's way off of my graph. And then I have 1.7, -0.7, so kind of here. All right, so now my end behaviors. This is important to know how to start my graph. These end behaviors are both infinity. That means this is up and this is up. So I'm going to be, that's my left end behavior. So it's going up. So I'm coming down. I'm coming down, 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 down to this. And then I'm going up through my y-intercept. I'm going up to this point, and remember we said it bounces. As a multiplicity of 2, it bounces off, goes down to that local minimum, and then goes back up. And again, they both are pointing up, which is good because that's what I said my end behavior was doing. So there's my graph of this equation, and it matches with what I have on my calculator. I would definitely always check on your calculator. And even if you don't want to zoom it out, but you do want to see the bottom, you can just change your y minimum just to see what's actually happening down here, so you can see it maybe a little more clear of I'm going down, 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 up, bounce, back up. All right, let's do one more on this video. So let's try this next graph. So again, I've got to find my zeros. So those are x-intercepts. So just like last time, I'm going to set these all equal to 0. So to find x-intercepts, which are zeros, I'm going to do x plus 3 equals 0, x minus 2 equals 0, x minus 4 equals 0. And I get x equals negative 3, x equals 2, x equals 4, and I want to write those as an actual xy. So negative 3, 0, 2, 0, and 4, 0. My y-intercept, I'm going to put zeros in for all my x's. So if I put a 0 in here, I get 3. A 0 in here is negative 2 squared, which is 4. So 4 times 3 so far is 12. 0 in here is negative 4. So that's negative 48 times 1/2 is negative 24. So 0, negative 24. And you can just use the stow button on this. I could do this. I could do 0 stow x, and then just put your equation in. So alpha y equals 1 over 2 x plus 3 x minus 2 squared and x minus 4. And it tells me negative 24. All right, so my end behavior here, that's an x. Those are 2 x's, right? That's x squared, so I would write this twice. So I have 2 x's, another x, another x. Again, x to the 4th. So this is an even function with a positive leading coefficient, which means both of my ends are going up, touchdown. It looks like a touchdown, they're both going up. So that's infinity, that's infinity. But again, we need to graph it anyway to find our maximums and minimums, so you might as well look at the graph after you put it in. You don't have to memorize that kind of thing. You can look at the graph and figure it out. So alpha y, whoops. Okay. I'm going to go to y equals, alpha y equals, put my 1/2 x plus 3 x minus 2 squared and x minus 4. Hit graph, and my window is still from my last one, but it actually turned out to be helpful because I am going to kind of want to go down a little bit more. So there's my graph. I can see both ends are going up forever. I can't see the bottom yet, so I'm going to go to my window and change my minimum. And I probably should have looked at my table first to see how far down. It looks like I'm going down to negative 48. So when I go to window, let's maybe change my y min to negative 50 and see if that works. Yes, so now I can see how it's going down there, coming back up, going down, going up. All right, so again, for my maximum, second calc number 4. This is one of my local maximums here. Go to the left of it, hit enter, go to the right, hit enter one more time, and it tells me that my maximum is 2. And again, this is saying 2, 0. And if you're not sure, go to your table and look. When you get a number like this on your calculator that's very small, it typically means 0. So I want to check. I'm going to go to my table and see, is 2, 0 a point? Yes, 2, 0 is a point. So I'm going to write 2, 0. I'm not going to write that number that it gave me. I'm going to write 0. Go back to graph and do second calc number 3 for minimum. So here's one down here. I might do this one first because I'm closer to it. So I'm going to do this one. So left of this little bump, right of it, enter one more time. And one of my minimums is 3.4 comma negative 3.8. So again, I'm rounding right now to the nearest tenth because I can't really even graph tenths very accurately on my grids. So it definitely doesn't help me to go all the way out to the hundredths or to the thousandths here because my grids are only by ones. So already tenth is kind of an estimation when I'm graphing. So my other minimum, second calc 3, is way down here. So I'm going to move my cursor to the left, to the left of this spot, hit enter, move it to the right, hit enter one more time, and my other minimum is negative 1.6, negative 50.8. All right, so now I can graph. I'm going to put my x-intercepts in first, my zeros. So I've got negative 3, 0, 2, 0, and 4, 0. My y-intercept is going to be off. It's going to be negative 24. It's going to be down here somewhere. I have a maximum at 2, 0. And again, that's because right here, do you see this 2? This is another bounce spot because it has a multiplicity of 2. It's repeated 2 times. It's x minus 2 times x minus 2. My minimums, I've got 3.4, so 1, 2, 3, and then negative 3.8, so 1, 2, 3, probably right around here. And my other minimum is negative 1.6, and it's way, way down here. This is not going to be very accurate, negative 50.8. My end behaviors are both pointing up. So I'm going to be coming down from here, going down, 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 down here, then to my y-intercept, up to this x where it bounces, goes back down and back up. And you can see that kind of looks like my calculator graph. Always check these on your calculator. There's no reason not to when you have a calculator.